I'm going to show you just a couple simulations to illustrate the power of an HR diagram. So as you saw before, an HR diagram is really a graph of the temperature on one axis and the brightness or luminosity of a star on the other axis. And so every star in a cluster would fall somewhere on this graph. It has a certain brightness and a certain temperature. Now the day all these stars are born, they fall onto this so-called main sequence, which is roughly a straight line right across the diagonal of this HR diagram. But as time goes forward, what happens is these stars use up their fuel, and the more massive stars, which are on this side of the graph, they use up their fuel the fastest, just like a big fire would use up all of its firewood faster than a smaller fire, right? So it's going to start to change, and so we can actually watch what would happen to an HR. Now we can't do this with real star clusters, right? They change so slowly we can't see how they would change, but we can simulate how star clusters would appear to change. So watch what happens as I make these stars sort of age. You'll see the oldest stars start to peel off and they start becoming giants, right? So they're actually getting bigger as they move up to this part of the spectrum of the diagram. All right, so you start to see they kind of turn off, and it kind of works its way down the main sequence where these stars are running out of fuel, becoming giants, and you'll see they disappear because they're actually very quickly moving from being giants way down below to being white dwarfs. All right, we'll learn more about what's actually happening in that process. But right now I just want you to see how they kind of peel off the top, right, as the cluster gets older. And now check it out. The cluster, I can actually see the age of it down here. It says it's 40 million years old. We can simulate these things really accurately. And so I know that by that point, these stars, which are now starting to be maybe getting close to the kind of the size of our sun. Our sun is more like down here. All right, are kind of peeling off. They're peeling off, right? Now here's what's really crazy. When we look at star clusters, we'll see them at different stages of this process. So here's a really cool simulation. Now I can take a real cluster data and put it on top of here. It's the same thing. HR diagram is temperature and brightness. And this red line represents the main sequence, sort of the theoretical main sequence. Now, if I find a really young cluster, like the Pleiades, you'll see that these stars are almost all right on the main sequence. Again, this is like real data of the stars. You see it's just starting, these really massive stars are just starting to kind of peel off the top. So I can actually tell how old this star cluster is. It's kind of amazing that we can measure the age of something in the sky. Now if there's older clusters, what we'll notice, oh, here's one, right, where it's a little less on the main sequence. Some of it is kind of peeled over. We see more of these giant stars. And I can even see something really, look at this, looks just like the simulation, right? Where it's peeled off and I have now some of these giant stars. So this is an even older cluster. So we can really, by making these HR diagrams, we can not only sort of categorize these stars to say, are they main sequence, or are they giants, or are they white dwarfs, but we can actually measure the age of a star cluster. It's really amazing.